I'm going to do some examples here to help you with the homework 2.2. Suppose we have a function f of x equals 5x minus x squared. When I look at that, I would rewrite it as negative x squared plus 5x. Now, as I look at that, I see that the leading coefficient is negative 1 and the degree is 2. That tells me it has the same end behavior as this function, y equals negative x squared. So I know from looking at that this graph will rise to the left, fall to the left and fall to the right. Now I'm going to find the zeros. So when I factor this, I get negative x times x minus 5. So the zeros are 0 and 5. So if I plot 0 on the x-axis, plot 5 on the x-axis, I know that the graph goes through those 2 points. So therefore it must fall to the left, and I look at that as it rises as it enters the picture, goes up, turns, and comes down. So the graph looks like that, which fits what we know about a quadratic equation. This is a parabola because of the degree is 2, and it opens down because the leading coefficient's negative. So it fits that as well. Looking at another problem, suppose I have f of x equals x cubed plus 3x squared minus 4x. When I look at that, I see that the degree is 3, and the leading coefficient is positive. What does that tell me? That tells me it will have the same end behavior as the graph y equals x cubed. So it will fall to the left, rise to the right. Let's find the zeros. To do that, I'm going to factor it. So I get x times x squared plus 3x minus 4. That equals x times x plus 4, x minus 1. So the zeros are x equals 0, negative 4, and 1. So using what I now know, the zeros are 0, negative 4, positive 1. Since I know the graph falls to the left and rises to the right, I know it's got to look like that. So what's it do from negative 4? It must go up, and it's got to come down to go through that 0, down, and then up. So I know my graph looks like this. What I don't know, and I really don't care about at this point, is how high or low these relative maximum and relative minimums are. That's the graph I'm looking for. Let's look at another example. F of x equals x to the 5th plus 2x to the 4th. What do I know here? The degree, that's supposed to be a 4. The degree is 5. The leading coefficient is positive. That tells me that the graph, the degree equals 5, that tells me that the graph is the same shape, same end behavior as this graph. So I know it's going to fall to the left and rise to the right. Now I need to factor this. So to factor it, I'm going to take x to the 4th times x plus 2. That tells me that the zeros are 0, negative 2. However, as I discussed in class, since the degree is 4, this 0 has multiplicity 4, which tells me that it's a turning point. Anytime the degree is even, anytime the multiplicity is even, the 0 is going to be a turning point. So I have a 0 at 0, I have a 0 at negative 2. And I know that this graph falls to the left, rises to the right. Well, how is it possible that this graph could go up and down and go through this point? Well, because 0 has multiplicity 4, this is a turning point. So the graph does this. There's my two zeros. Here's my end behavior. So that's what this graph looks like. Trying another one. F of x equals negative x to the fifth plus 4x cubed. Negative x to the fifth plus 4x cubed. The leading coefficient is negative. The degree is odd. That tells me it's going to have the same end behavior as this graph. It's going to rise to the left and fall to the right. If I factor it, I get negative x cubed times x minus 4. It's actually x squared minus 4. So I get negative x cubed times x plus 2, x minus 2. So my zeros are x equals 0, negative 2, positive 2. But this has odd multiplicity. That tells me there is an inflection point. Now, WebAssign will say it crosses through at 0. But if the multiplicity rather is greater than or equal to 3, it's an inflection point. If the multiplicity is 1, the graph merely passes through the point. So when I graph this, the zeros are negative 2, 0, and positive 2. I know the graph falls to the right, rises to the left. So what does it do at negative 2 and positive 2? It passes through. It passes through. But what does it do in between? There's one of those funny inflection points there. So the graph looks more like that. Okay, and not easy to draw this, but that's the basic idea of what that graph looks like. If you do this on your calculator, you'll get a better idea of what the graph looks like. Let's look at one more here. F of x equals x to the fourth plus 3x cubed plus 2x squared. The degree is 4. The leading coefficient is positive. That tells me the graph has the same end behavior as this graph. So it's going to rise to the left, it's going to rise to the right. So if I factor this, I get x squared plus 3x plus 2, which is x squared times x plus 1, x plus 2. So now I know my zeros are 0, negative 1, negative 2, and this 0 has multiplicity 2. What does that tell you? It's a turning point. So when I go to graph it, there's a 0 at negative 2, there's a 0 at negative 1, there's a 0 at 0. Because it has the same end behavior as this graph, I know it rises to the left, I know it rises to the right. So what does it do in between? Well, let's see. 0 is a turning point. Negative 2 and negative 1 have single multiplicity. So it passes through, comes down, and turns. So this is what this graph looks like. What if I had one already factored? That makes it easy. If it said f of x equals negative x minus 1 quantity cubed times x plus 2 to the fourth. I look at this and I know if I were to multiply it out, the degree would be 7. I know that the leading coefficient would be negative 1. That tells me it has the same end behavior as this graph. It rises to the left, it falls to the right. So it's already factored for me. How convenient is that? So the zeros are 1 and -2. This 0, 1, has multiplicity 3, so it's an inflection point. This 0, -2, has multiplicity 4, which is even, so it's a turning point. So when I graph this, I know the zeros are -2 and +1. I know that at negative up and the end behavior, I know it rises to the left, falls to the right. Actually, I'm wrong. No, that's correct. Okay, so -2 has multiplicity 4, it's a turning point, so I know that it goes up and it comes down, and I have an inflection point here. So the graph looks like that. Finally, what happens if I'm given a graph and I'm asked to find the equation? Suppose I have a graph that looks like this. Let's see, -1, 1, 2, 3, 4, and let's suppose the graph does this. Oops, that's supposed to go through -1. This is not easy to do with these styluses, or styli, it's a stylus. So this graph looks like this, sort of like the state of Michigan. I look at that, and because of the end behavior, I know the degree is even, and I know the leading coefficient is negative. I know the zeros are -1, 1, and 2 has multiplicity even. So I know the factors are x plus 1, x minus 1, x minus 2. So that tells me my equation is going to have, let's see, a negative in front. It's going to have x plus 1, x minus 1, x minus 2. Now I know this is wrong because this would have an odd degree. What I'm forgetting is the multiplicity of this 0 is even, which means I have an even exponent here. I can put it that way. So this equation would have a graph that looks like that. What's interesting is I could change the equation. I could put numbers here that would change, that would stretch or shrink the function, but the zeros would remain the same. So I could get a graph that looks like this. Oops, I didn't turn it there. Let me erase that. So I could get a graph that looks like this. It would be a stretch. I could get that by putting a 2 in front here. I could also get the same shape if instead of a 2, I put a 4 or a 6 or an 8, because then it would still have even multiplicity. I hope that helps as you do the homework. Good luck.